Hello viewers, we get straight into solving question B6 of 2025 GCE Science Paper 1, the past paper. We are going to straight away go to this question, and the question shows rays of light in a semicircular glass block. Okay, so we have this diagram here. Now this is under light basically. Now if it was a rectangular glass block, possibly there was gonna be some ray of light entering this rectangular glass block at a certain angle other than 90 degrees, and you would see it bending. But in this case, you will notice that the ray of light entering this glass block, for example AB, CB, and the one leaving the glass block, which is basically reflected, okay, on the boundary of the glass block, which is this one. So you realize that they are entering this light. There is nothing that is showing to sort of bend, or the refraction process is seemingly is not appearing here. And the reason is simple. Basically, what you need to understand is that the ray of light AB is entering the glass block at 90 degrees. That's the reason why you cannot see this bending here, okay? So in layman's language, you would say it is entering the glass block through the normal. That is in layman's language. But you can say technically that it is entering the light at 90 degrees. If you were asked the reason why it is not bending, because these are common questions that you need to devise as you are going through this diagram. You know, one thing that you need to do is to read the question, reread the question, begin to draw some things that you can be able to see, and begin to try to fill up some missing names or answers, so that as you go to the question, you will have already exhausted this part. Okay, so now here we are saying that this is a ray of light. Now there is another thing that you need to observe here. This thing that you need to observe is that there is something funny here, okay? Because this ray of light, as it enters, it is reflected back. It is not refracted, but it is reflected. Okay, why has it been reflected? It has been reflected because, remember, there is what we call critical angle. And if we look at the question here, the question basically asks you to define the critical angle, which is basically the angle of incidence, which basically gives the angle of refraction of 90 degrees when a ray of light is moving from an optically denser medium to an optically less dense medium. That is what we call the critical angle. Now, what it means therefore is that as you are looking at this semicircular glass block, if this was the critical angle, okay, if this was the critical angle, you would see the angle of or the refracted ray being here, okay. That is what it means. So the critical angle now, the critical angle is the angle of incidence. Remember, the light is moving from a denser medium to an optically less dense medium. So the critical angle is the angle of incidence, which gives an angle of refraction of 90 degrees. So this angle of refraction is 90 degrees, okay? And then this is the critical angle. So it is the angle of incidence, which gives the angle of refraction of 90 degrees when a ray of light enters an optically less dense medium as it comes from an optically denser medium. So that is what a critical angle is. But when we adjust this, okay, when we adjust this and it comes here, you would find that this is now bigger than the critical angle and it is going to reflect. That is basically the explanation there. So the reason why it is being reflected back is because the angle of incidence is now bigger than the critical angle, or larger than the critical angle. That is basically the reason why it is being reflected. And this is called total internal reflection. Okay, total internal reflection basically. Okay, so now let's go to the question. Define critical angle. Well, critical angle is basically the angle of incidence which gives, or that gives, an angle of refraction of 90 degrees when a ray of light is moving from an optically denser medium to an optically less dense medium. That is the answer. Explain why the ray entering the glass block at A is not refracted. Well, because the ray of light entered the glass block at 90 degrees. Then explain why the ray of light AB is reflected and not refracted. Okay, exactly what we were explaining, to say because the angle of incidence is greater than the critical angle, and hence the total internal reflection does what occurs. Those are some of the reasons. So to write this, these are the answers below. Yeah, so these are basically the answers to that question. Then we move on to question D. On the diagram, complete ray CB to show the approximate path it takes as it leaves the glass. So do not even use a ruler here. I mean a 30 centimeter rule or whatever that you are going to use. In terms, I mean, not a rule, but a protractor. That's what I meant. Excuse my tongue for saying a rule. So here you just have to use a rule, not a protractor, because you've been taught to show the approximate. So here the guide is that as it leaves the glass block, CB, as you can see, is closer to the normal, okay? And this means that it is less than the critical angle. So you don't expect the refracted ray to be at 90 degrees to the normal at the boundary, no? But you expect it to be slightly above the boundary, or it should be it should be, it should bend towards the boundary more than it would bend towards the normal. Okay, I hope you are getting that. So you expect it to be refracted in this manner, like that. So to complete the diagram, this is what we are going to write. So this would be the diagram, you would have something of this nature. Okay, because you are asked to say draw, okay, complete ray CB. Okay, so this ray CB is just ending here, so complete it as it leaves the glass block. So like I said, it would be slightly here, somewhere here. So what the examiner, and this is the production of this data, and what the examiner is going to mark is any correct refracted ray shown between the normal and the boundary of the glass block. This is what the examiner will mark. Any normal and any correct refracted ray. So you don't expect it to be close to the normal, but it should be away from the normal. Those are some of the things that you need to pay attention to. I hope this video was helpful, and let's call it a day. Bye-bye.